Hi, everybody. My name is Andrew Van Bakel. I'm the Regional Director of Eastern Ontario for Keller Engineering. Today, I'm here to talk about attic issues and roof ice damming. What is ice damming, or sometimes referred to as attic rain? The terms are used interchangeably, and I'm sure it's something a lot of you have seen, especially living here in Canada. So what ice damming is, it's the formation of ice at the eaves of your roof, and it's due to heat accumulation in your attic. So in the winter, when your homes are heated, some of that heat bleeds out from the inside into your attic, and then all that heat can melt the underside of the snow on your roof, turns into water, starts to flow down the roof, and then as it passes the exterior wall, where it's no longer above the heated space of your residence, it freezes. And then this process keeps happening and the ice gets thicker and bigger on the eaves of your roof. Attic rain, on the other hand, is more about moisture inside the attic. And so when you get that air leakage or heat inside your attic space, that warm air, which holds a lot more moisture than cold air, it comes into contact with colder surfaces such as the nails or fasteners going through the shingles on the underside of the sheathing, or even truss members or the sheathing itself, and it could frost because that water is condensing out. And then the springtime, when everything gets all that melts, and it gives the appearance of rain or moisture inside your attic. So why are these bad? Well, it can cause wood decay, organic growth inside your attic space, water entry into your units, which cause interior finishes damages, reduce the thermal performance of your insulation, so your heating bills are higher, cause damage to natural shingles, and there's just resident safety from a lot of large icicles hanging off the side of your building. So the three main factors that cause ice damming are the airtightness of your attic floor assembly, the ventilation within your attic space, and the thermal performance of the insulation of your attic floor assembly. So the ideal attic will be the same temperature and relative humidity as the exterior. If it's minus 20 outside in the winter, your attic should be minus 20. And the way most conventional attics work under sloped asphalt shingle roofs is air is coming in through the soffit overhangs and through those vented perforated soffits, circulates around the attic, and then exhausts out through the ridge. Attics can come in all different shapes and sizes, and a lot of them have separate sections that are in between firewalls and breaking up units. So air tightness. So in reality in construction, it's very difficult to achieve perfectly airtight attic floor, right? Because you're going to have all these penetration, hatches, lights, bathroom fans. So there's always going to be some bleed out of warm interior air in the attic space, but we need to minimize it as much as we can. So your typical attic floor assembly is you have your drywall ceiling, and above that you have your air vapor barrier, which is that polyethylene sheet. And then above that you have your loose laid insulation. So some common penetrations in the attic floor can be your hatch. So normally that has a seal, and then there's weighted insulation on the top of it to actually compress that seal. So you see in the top left photo here, we have frosting around the frame of the hatch due to air leakage. Bathroom fans are a big one too, right? There's a lot of humidity and warm air in your bathroom. You do not want that exhausting into your cold attic where it can condense. So it's the connection of the fan itself at the attic floor and also the connection to the roof. At the same time, that roof seal, if it isn't airtight, you see all the frost in the bottom left picture on the underside of your sheathing because it's exhausting that warm air from the washer. Ceiling lights, pot lights, you have your electrical wiring, and then just the general installation of the poly too. Are the joints taped? Is there any rips, punctures in it? So on and so forth. Next is ventilation. So we said it's very hard to achieve an airtight attic floor system. Ventilation is your fail-safe. It will passively remove any of that moisture-laden air or heat that accumulates within your attic space to eliminate any issues. So it's really important that you have good ventilation. The typical rule for in Ontario, Part 9 buildings, is for most slope roofs, which are greater than 1 in 6. You take the surface area of the attic, divide it by 300, and that's the amount of net free ventilation you have. And you can't have all your ventilation at the ridge, or you can't have it all at the eaves. It's got to be a combination of both. One of the most important things to consider is baffles. So that's making sure your attic insulation is not blocking those soffit vents. So install baffles between trusses. They can be pieces of plastic or cardboard that allows that airflow to come in from the outside into your attic space. Your vents at the ridge, there's strip vents, there's low profile, there's high profile. You want to make sure those are adequately sized for the amount of ventilation you need. And low profile ones can get blocked by snow as well too. So something to consider. Placement of your vents. You want to make sure it's properly situated over the actual hole in the sheathing. Otherwise, it's not going to work to its full capacity. And don't place it near a bunch of other vents because short circuiting can happen where air just as it exhausts out, it kicks around and comes right back in. And each section of the attic in between firewalls would have to have its own venting. Lastly is insulation. So insulation doesn't stop heat transfer. It just reduces the rate at which it transfers, right? So the more insulation you have, the less heat that is going to be into your attic or transferring into your attic, the rate. New residential buildings have an attic insulating value of R60. Older buildings, you'll find it can vary widely, but they're commonly around R20 to R30. So your new attics looking at probably like 18-inch of insulation. Older attics, sometimes they have 6 to 10 inches. Insulation is installed above the air barrier. So the air barrier or that poly sheet is on the warm side. Therefore, any air which hits it is not going to go up against a cold surface because it's below the insulation. Spray foam insulation is a good option to seal some tricky things in your attic, like around the hatch, ceiling pot lights, bathroom fans. And there's always going to be thermal bridging. Heat takes the path of the least resistance. It can go through the truss cord, so make those are kind of covered through insulation as well too. Defects. You want to make sure your insulation isn't saturated or wet. Insulation relies on air to provide its thermal performance. So if it's wet or if it's been compressed, that'll reduce its effectiveness and more heat will go through. You want to make sure it's evenly distributed through your attic. If you have 2 inches over here and then 14 on this side, a lot of your heat's going to come through that spot for 2 inches and it's not going to help much. You want to make sure it's not missing. You want to make sure the soffits aren't blocked. So in conclusion, what do you do if your unit or some units in your complex have ice damming and you're seeing all those large icicles, or you've been getting reports that there's moisture issues in your attic space? So I think first step is looking at completing attic inspections, whether that's a sample of units or one unit by its own. There's lots of different options, but it's most easily done in the winter because that's when the issues are going to be the most prevalent and easy to see. It's a lot easier to see frost and know, oh, this is where the air leakage is coming in versus when you're doing it in the summer months. Look for the common big ticket items when you're doing those inspections. Block soffits, bad bathroom fan connections, poor insulation condition. Make sure it's all spread out. There's enough of it in there. Make sure the attic hatch is sealed. And then typically these start with, after doing that, do a bit of a ventilation check, right? Does it meet the minimum code requirements? Were the vents installed properly? Great ventilation in your attic can hide a lot of the defects from attic rain and ice damming. So after that, you kind of get that information, and it's a bit of an iterative process, right? We typically recommend, doing some ventilation and air tightness problems first, addressing those, and then monitor to see if it gets better over time. And then if you have to, go to the next higher intensive steps, like adding a bunch of insulation, checking the poly air vapor barrier for any defects, things that are a little more expensive and time consuming. That's all I have here. Once again, Andrew Van Bakel, Keller Engineering. We're a multidisciplinary engineering consulting firm with offices across the country. Our info is here if you want to reach out for any of your condominium needs. Thank you very much, and hope everyone enjoyed this presentation.